All right, guys, welcome back to the second part of the first part of Unit 2. I know that is very confusing, and I do apologize, but I honestly figured I was going to take a little longer to cover firewalls. That's why I want to split this up, but I am a man of my word. So now let's move on to security appliances. I should say appliances, but whatever. And I don't mean appliances like an iron. I mean like appliances, like all the stuff I talked about so far. I've talked about firewalls, right? Talked about UTMs. I haven't talked about IPSs. This is just everything that makes up a security appliance in general. Any one of these are considered security appliances. I'm not going to cover all of them, sadly, because I don't. I believe. Maybe. We'll be fine. Don't worry about it. Network access, I talked about UTM, network access control. It's just straightforward is who has access to the network, who has only certain parts access on what virtual LAN, which I will get into in the next part. Virtual LANs are kind of pain in the butt. Email security gateways, web application firewalls, VPN gateways, network device backup and recovery. Let's get into it. Let's dive right into this. So I talked about firewalls. I'm not going to talk about firewalls anymore. So actually, I do talk about everything except firewalls because we just covered all the firewalls. So, intrusion protection system, network-based intrusion protection systems proactively monitor all the traffic going through your network. So they just scan your stuff. It's going in and out of the network. It's not hard to really figure out what IPS does, right? Using pre-made profiles, signature detection, artificial intelligence, and AI is now used actually in that too, and anomaly detection. So things just might look weird and not behave properly. And then they might try to inject a bunch of packets, packet injection. It'll trigger it. IPS systems can detect many kinds of network intrusions, from malware on endpoint devices to denial of service attacks. You know what a DDoS is? So yeah, this is gonna be simple. I know, but it's just so you get an idea what DDoS is. Let me do this. I'm just pinging CNN. You can see how many packets I get back. This is me replying. 4 packets sent, 4 packets received. I'll make this a very simple lab, probably, just because I'm curious on something for your 2 virtual machines that you'll have soon. So it's essentially a DDoS attack is you pinging constantly. So that's also called a broadcast storm. I don't know if you guys ever heard of the term called IoT, Internet of Things, like smart washer, smart dryer, smart fridge now. What's next? Smart milk carton, hypothetically. I'm kidding. All those things are in reality are a base computer, and they can be hijacked in the sense of hackers, air quotes on the hacker part, can get a hold of them and just take them over and make them do basic commands like ping. Well, all your Fire TV 2 or your Amazon, your Chromecast or Smart TV, all that, they're all computers, right? And they can be taken over remotely in that sense. And it's not like they're going to do any damage with the stuff that's on there. You can watch Netflix or whatever, or what have you. But they can all make them ping. And if they all ping constantly, if it's one device, it's not a big of a deal. It can be filtering out. Oh, it's 500 devices. Yeah, gets pretty hairy. So that's what a DDoS is, in essence. One of the most useful features of network-based intrusion protection is that it can talk to firewalls, which I talked about firewalls earlier, and other network hardware in real time as threats are discovered. So it can update rules for firewalls. It can talk to everything else like the router. Hey, don't let this go through. Hey, don't do that. Turn off this port on switch 4 or whatever. So then we talked about unified threat management, UTMs, combined with network firewall. I talked about an intrusion detection system, an intrusion prevention system, and other features, antivirus. For smaller businesses or those without significant IT resources, using UTMs can save lots of time and money. You see more of these in small scale enterprises like coffee company, not coffee companies, not coffee. Like Starbucks, for example, when they might use UTMs in conjunction with other stuff, but they'll have more than just a UTM. I'm talking like small mom and pop stores, like a small local chain, they'll use UTMs to save money because maybe there's 2 IT guys over the whole thing. What if it's like your favorite, hamburger place and they have like 4 not stands, stores, and they're a regional chain, and they have like one whole guy for the IT department that has to handle POS is point of sale, by the way, like cashiers. It's called point of sale device. The drive-through mics, all that's network, that kind of stuff. That's what I'm referring to. They would use that in that instance with the poor one guy. I hope he makes a good salary, or she makes a good salary, or they make a good salary, whatever. But you'd like to use this. Cool with me, just let me know. So let's move on to network access control. Keeping infected or insecurely configured endpoint devices. Endpoint devices are phones, tablets, like an iPhone, an Android tablet, laptops, desktops off of the corporate network is critical to security. As a result, network access control devices link network authentication with the state endpoint devices. What? Huh? Essentially, it's a gatekeeper. And when you connect, let's say, it's a work issued laptop, it's supposed to have what's called a wireless network certificate assigned to it after you logged in. And it's your certificate. You can't see it, but it's now hard baked into your laptop. And if there's been any changes or detect anything weird coming from the laptop, it'll tell the certificate's invalid and block you from connecting. That's how that works. Email security gateways. Well, more and more businesses move to cloud-hosted email solutions. So we recently did this migration. I'll be honest with you guys, it was a pain in the butt. It took about 3 months to figure everything out for people being moved. And because people don't read emails, not saying it was me, but staff, I won't mention anybody adjunct or anything of that nature. It's a lot of people won't check their email. So they okay, log in one night and they can't log in the next. Well, what happened? It's asking for this login for Outlook. We used to do what was called on-site hosting, which means exactly what it says, on-site. We had all of our mail servers on site at our district office. Now we're like, hey, Microsoft will pay you a bunch of money to move it to the cloud with our engineers, and you can handle all the mailbox sizes and stuff. Cool. So that's kind of what we went through, but neither here nor there. These devices monitor, just you guys know, it's just a pain in the butt when you move the cloud. Sometimes these devices monitor incoming and outgoing email traffic for spam, viruses, phishing attempts, and compromised accounts. We have one of these at work, and I get a report every week and a half. Told me, hey, this is what came. It stops literally all spam, almost like 99% of the external stuff that come in, because I believe it or not, I get a bunch of Old Navy emails for some weird reason. Now they don't come in anymore. They're blocked because I told them to block it. And we do have stuff coming in from the outside, like from HP. We need support for some of our devices. Dell, we need support for some of our server parts, stuff like that. So it knows what's to filter, what not to filter. It's pretty cool. Maybe I can get a picture of it. I'll talk to my security guy. Recent advanced email security gateways also use historic data and statistical analysis to detect anomalies with more accuracy. Web application firewalls, like a regular network firewall, right? A WAF, that sounds really funny to say to me, selectively allows or blocks traffic based on predefined criteria or suspicious activity. Web applications commonly have security vulnerabilities that can be used to compromise a company's network and leak data. Moving on. I guess I did talk about everything. Sorry about what I said earlier, guys. I was thinking for some reason I wasn't going to cover all the stuff that makes up security appliances, but I guess I did. And my brain just isn't all catch up all the slides I've made past 2 days. So VPN gateways. With the rise of remote work, yay, remote work, right? Every company needs to ensure that their internal network resources are accessible securely from anywhere. A virtual private network, that's what VPN stands for. Or VPN, which that's right there, right? Can help here. In effect, when employees connect to a VPN, their traffic enters the internal network from VPN devices instead of going straight to the internet. It's like having a side tunnel. Like, let's say you're going to Folsom. You're on the 99. Hopefully I picked the right freeway. And you say, hey, tunnel to Folsom on the right, direct path. And all this traffic in front of you is just going on for miles, just red lights. You're like, oh, I can take this tunnel and take me right to Folsom. Cool, let me go through the tunnel. That's how VPN works, essentially. Just sidesteps all the regular, it just creates a straight tunnel from your machine to your company's office. Like when you see me remote in, that is me VPNing into work. It's connecting my main desktop here at my house to my main desktop at my office, which is a very ancient Dell. I'm not going to get into it. That's a VPN that we're using. So network backup and recovery. With so many individual network devices, applying or rolling back configuration changes can be challenging. But here's the thing about that. You usually test all of this stuff, like when a server, if you're going to do an update or a big patch, you make a virtual machine, like I have had you guys make one so far, and you test it on that virtual machine with the most current image, which would be like whatever you're running today. Let's say it's version 2004, and you're going to patch to 2102. Just throwing it out there. And you're like, all right, let me update it and later just turn it on and run some tasks and see how it behaves. Because sometimes something breaks, something normally breaks no matter what you do. It's something so minor, like, let me see a blue screen error. I'm thinking about it off the top of my head because I'm trying to remember like some of the errors I've seen when stuff happens. Here's a real common one that I don't think you guys even see anymore. It's just a picture from Google. This is, it doesn't really matter where I get it from, right? But this, let me make this bigger. I don't care if you see myself up here. I'm not hiding anything. But this right here, IRQ not less or equal, was a very common blue screen back in the day. Like I'm talking Windows 98, Windows XP, like just came out days. But That's why you need backup. That's why you test it. So if that happened in your virtual machine, can't let it crash, restart the virtual machine, so frying your whole tower or whatever. Then go through your event viewer, which I'm going to pull up right now. This is what event viewer looks like. So you've seen it. So you see this every day. I'm talking about you, Dante. I know. I'm not saying none of you haven't. Just some will see it more than often. But if you go to your event viewer, Windows logs, and you have all this, right? System. See, I get warnings, but as long as I don't get errors, like that's a problem. This server, yeah, it's not big. That's what I'm talking about. You'll see a big red error. It'll tell you like this happened, and then it'll have the hierarchy notice or equal code. And you can look it up. But again, that's backup and recovery kind of falls into that area because this is just troubleshooting stuff, guys. I'm talking about. But what I'm saying is, this is why you test before you do anything. Additionally, large numbers of separate devices are difficult to recover quickly in a disaster. But yeah, segueing out of it a little bit, but I'm hoping making sense of what I'm saying. Praying I'm making sense of what I'm saying. So let's get into meat and potatoes of virtual landing, which is about 20 slides deep. So do bear with me. I don't VLAN too often. I haven't made a VLAN like in 2 years. I'll be very honest with you guys because I don't do networking that often in that capacity. Me for networking now is like, hey, make sure it's static. Hey, make sure this is enabled. Hey, make sure this, copier has SMTP enabled so we can do emails directly from it. Anyways, so what's VLAN? So V means virtual, LAN means local area network. Pretty straightforward. A virtual local area network, VLAN, is a virtualized connection that connects multiple devices and network nodes from different LANs into one logical network. Okay, so over here on the right, I have what's called VLAN segmentation. These computers are all on one virtual network going through one hub to a router, which the picture got cut off. I do apologize. I have better pictures. These are on VLAN 2, and these are on VLAN 3. You could have accounting in here. You could have graphic designs department in here. You could have human resources on this virtual LAN, just so they're all separate. Organization. VLANs provide segmentation based on broadcast domains, which you essentially take a port and make it into a whole network with another port at the end. That's kind of how the whole port, acts as the network. It's some weird stuff, I know. VLANs logically segment switch networks based on the function, project teams, or applications of the organization, regardless of the physical location or connections to the network. So I'll give you an example. In my office, I'm on what's called the N side or non-instructional side. So my range is 192.168.30 to 35 dot whatever. And we have what's called instructional, 192.168.20 to 29 dot whatever. So that's how they're separated into two virtual LANs. And they do more virtual LANs per floor. It's weird. I didn't make up the rules. Anyways, where was I? Communication among VLANs still require a router, which is this brown guy here. But only one physical connection will handle all the routing. That's why one port is only used to make a VLAN. Moving on. VLANs are created to provide segmentation services traditionally provided by physical routers and LAN configurations. They address scalability because then you can turn like a 48 port switch into 48 VLANs if you really wanted to. Scalability, security, because it's all separated, compartmentalized, so all on different sides of the network, right? They can't, they can say they get into the engineering one, they can't get into marketing, they can't get into sales, they can't get into HR, it's all separate. Network management, so you say, hey, there's a problem with the network on the engineering side, well, it's only going to be this cluster of computers might have the issue, not everybody. It doesn't cascade in that sense. Unless your whole switch dies, and that's a whole different animal, but we won't go into that. Broadcast filtering, so there's no collisions in the domain, and traffic is nice. Traffic flow management. Yep. Switches may not forward any traffic between VLANs. This will violate the integrity of VLAN broadcast domain. I should make that bold because that's a very true statement about VLANs. Traffic must be routed between VLANs. So they can talk to each other, believe it or not, but you have to make them talk to each other. But that breaks what's it called in the router? That breaks it breaks something in the router. I can't remember the name because I just thought about it earlier and I just forgot. But traditionally a router won't let you do that, but you have to enable something. But I talk about that later. So don't worry, guys. We'll get there. So look at this. That's a router. I know it's not labeled. I apologize. The picture sucks. This is from a book. One physical link. And if you're wondering what FA means, it means this is the port. That's a switch. That's the port number. No, port. Something like that. I have it written down. Give me a second. I know. I'm so all over the place. Sorry, guys. I had it written down and I forget. So that means I have to tell you. I don't want to leave you in the dark here. It's a switch. That means switch. That means the port on the switch. Sorry, that's what I forgot. So that's switch 0, port 1. It could be switch 1, port 2, whatever. Sorry, I have a note about it in these slides. It's for you guys to know, for me to know. I mean, hey, it's better we know, right? So as you can see, engineering is its own virtual LAN. It goes here. Marketing is its own virtual LAN. And sales is its own virtual LAN. They will all connect to one port on this switch, only to that router, with only one physical connection. So for one physical connection, we took a port on this switch to make an engineering VLAN. You take one port from marketing, one port to make the marketing VLAN, one port to make the sales VLAN. So they're all separate. They're all secure in their own way in case one of them gets compromised. Let's say this guy clicked on something and didn't mean to, and then next thing you know, the computer has, oh, hey, we're going to encrypt all your stuff. Holy crap, turn off this port, and only these guys are down versus everybody's down. So that actually recently happened at work. A student plugged in a flash drive and didn't know it was compromised, and they compromised a lab. I mean, I'd rather deal with one compromised lab than an entire school. So, you know, that wouldn't be fun. So, what do VLANs allow? VLAN allows creation of groups of logically networked devices. So, like I said, sales, engineering, I don't know, if you had a makeup department like Macy's or whatever would have their own VLAN. Think of departments as like all areas, really, right? They'll all be segmented. Like administration will be segmented away from everyone else, yada yada yada. What's another one you guys can think of off the top of your heads? Tell me. We might make a group discussion. We'll see. Devices to act as if they are on their own independent networks. You know, they all act as their own themselves. The devices can share common infrastructure, like the network cable, right? Each VLAN is separate broadcast domain. Broadcast traffic is controlled. Each VLAN is a separate IP subnet. That's what I mentioned about having its own addresses earlier. To communicate along VLANs, you must use a router. Yeah, much more later. I talk about more. Security. Ooh la la, security. This is gonna be cool. Groups with specific security needs are isolated from the rest of the network group. Cost reduction. Cheaper. Needs for expensive hardware upgrade is reduced. Better use of existing bandwidth and links. It's cheaper to have VLANs and have more networks. Imagine how a lot of spaghetti running around and all the configuration, time, money. It's expensive. That's why. Higher performance. Divide larger, flat layer 2 networks into separate broadcast domains, reduces unnecessary traffic on each new subnet. Pretty straightforward. Broadcast storm, that's DDoS. Dividing a network into VLANs, as I mentioned earlier, prevents a broadcast storm from propagating to the whole network. So it can only affect one area. Like I said, it's the whole point of compartmentalization, guys. Just separate things out. Improve IT staff efficiency, easier to manage the network because users with similar network requirements share the same VLAN. So again, accounting is all with accounting. Repo graphics is with repo graphics. I mentioned repo graphics, graphic design. Accounting would be with accounting, HR with HR, et cetera, et cetera, et cetera. Simpler project or application management. Having separate functions makes work with a specialized application easier. For example, e-learning event platform for faculty. So they would only be allowed to use it on this side of the network from this area to this range to this range. That's all that means. Moving on. So let's talk about VLAN routing. It's the ability to route or send traffic between VLANs. Everybody said we're going to get to this. This is where we get into it. Are normally blocked between different switches. VLANs work at the MAC address layer. So it works on MAC addresses, right? I know. I'm not doing this to show off. I promise. So check this out. There are my MAC addresses right there. So if I was on a VLAN, this is what it would use to identify them, depending on what I'm connected with. We're not using IPv6, I'll tell you that right now. So are they only IP addresses in that? Yeah, these have no media connection. Yep, those are my Macs. 1 second, guys. Let me pause it. I'll be right back. Sorry about that, guys. I had to double check. We're not my Mac. I was right. That was that's my IPv6 address, which I'm not using. Don't worry about it. I'm an idiot today. I'm telling you, out of it. See, physical address. That's your MAC address. That's my unique identifier here from my Ethernet connection. Here's my unique identifier. I apologize if you hear my golden retriever barking. Yes, I call it the puppy tax. I can show you pictures later. Same thing with my Bluetooth. They each have their own unique identifier. See, this means they came from the same manufacturer. A4, A4, C3, C3, FO, FO, 7B, 7B, Delta Echo 28 on 2C. That's completely different versus this up here. This is not even it's not even the same manufacturer anymore. See, completely different. That's all that means. So, virtual adapter, that's because I have virtual machines. But yeah, it has its own unique MAC. Again, MACs are unique. So we know VLANs work at the MAC address. That's how they look at everything. Instead of using IPs, which is kind of neat because hardware already has a unique MAC baked in, which is kind of cool. So might make that alive. You guys can give me your MAC address. I might have you guys give me your MAC addresses from virtual machines. That sounds like fun. Quick, right? Quick and dirty. Anyway, quick and dirty lab. Make it simple. I don't want to make stuff too hard. I mean, I can. Traffic can't be routed between VLANs at layer 2 based on MAC addresses. Wait, what? I just said they can. I feel like a moron. Excuse me. There's a way to route them. I talk about it further. I'm just getting confused. I'm sorry if I'm confusing you guys. That isn't my intention. If this is too confusing, tell me and I'll read you the lecture. It's not that big of a deal. Each VLAN is a unique broadcast domain. Computers on separate VLANs are by default not able to communicate. Each VLAN is a unique IP subnetwork. Yeah, that's right. To allow, that's what I'm saying, that's totally reading into it. To allow VLANs to communicate, we need the router to communicate among separate broadcast domains and unique IP subnetworks. Inter VLAN routing. That's what I was referring to. I'm so sorry, guys. That's all I was referring to up there when I mentioned about MAC addresses. I jumped ahead in my head. I don't mean to. So yeah, they each have their own range. It's talking about the very top of the lecture slide here. They each have their own unique ID range, which I mentioned earlier. But inter VLAN routing, so routing within the VLAN, is a process of forwarding traffic from one VLAN to another VLAN using the router. That's how you do it. That's where it uses the MAC address or whatever called. Traditional inter VLAN, there's three types. Traditional inter VLAN routing, router on a stick inter VLAN routing, and switch-based inter VLAN routing. Let's talk about the traditional method first. Traditional inter VLAN routing, I'm just call it VLAN routing for short now because it's a lot to say. Traditional routing requires routers to have multiple physical interfaces to facilitate inter VLAN routing. So multiple MAC addresses. Each interface is also configured with an IP address for the subnet associated with the particular VLAN that it is connected to. So they each have their own unique identifier. So 192.168.10 for the sake of argument, dot whatever, 1 through 15. You can only at least 14 items. You never count from 1. Don't ask me why. It's something to do with programming. In this configuration, network devices can use the router as a gateway to access devices into the other VLANs. And here's what that looks like. And here's the explanation. So I'm going to read the explanation. I will tone it down as much as I can. So if, let's say PCA, this guy here, in VLAN 20, right, wants to send the message to PCB, guy next to it, in VLAN 30. So over here, off to the right somewhere, right? Wants to send a message. PCA would check the destination IP address, IP4 address, in the VLAN. If it is not, it would need to forward the traffic to the default gateway, which is the IP address on switch 0, port 0. Hey, I got it right. So it's going to go through port 3. That's not a switch. That's a router. Hub. I remembered. Hub port 0, switch 3. I had it in here. Hold on. Sorry, slot 0, port 3. It's a slot. It means slot. Sorry, slot on the hub. I'm brain's fried today, guys. I'm so sorry. So it would, if it can't find it, it's gonna send it, hey, send it all the way up here to the router. Right? That's what it says. This IP address R1. Send it over here. This is the router. Send it up here, this guy. PCA then sends an ARP request to AS1, sends it back down. So it goes up and down. So it goes here, here. This will go here, right? For the physical address of R1. So it needs to have to find the physical MAC address of this guy. Once the router replies, so it says back, hey, this is my address, it goes back down. PCA sends the framework of the router as a unicast message, as one broadcast message out. Since AS1, the router, has slot 0 and port 0's MAC address, this guy, it can forward the frame directly to R1. So it just goes, hey, hey, boom, back into this guy. When the router receives the frame, it compares the destination IP address by referring to its routing table, we talked about earlier, so as to know to which interface it should be sending the data towards the destination address. So it's going to go, okay, you want to send it to PCB, let me find the IP, well, how many hops is it, how many jumps do I have to do? The router that sends an ARP request, it's part of networking, out to the interface connection to the destination VLAN in the case of fast Ethernet port slot 0, port 1. So it says, oh, it's over here on slot 0, port 1. It would say, hey, I got the message. And it would flood ports and send it to PCB. And that's it. R1 would then use this information to frame the packet and finally send it to, so saying, hey, go back to the router, like, hey, I found it, it's over here on this VLAN. Tell that to PCA, hey, get through this pass to this pass to get, it's like going through a bunch of doors, right? So you get there, then it sends the packet. That's how it works. If it doesn't make sense, I can talk about this in office hours more, okay? So let's talk about router on a stick. It's a sub interface. Overcomes the hardware limitations of a router. Yeah, so it overcomes the router's issues. Sub interfaces are software-based virtual interfaces that are assigned to physical interfaces. What does that mean? So it takes a software-based virtual interface that assigns it to a physical port. Each sub interface is configured with its own IP address, subnet mask, and unique VLAN assignment. So if you want to know what subnet mask is, I'll pull up my IP again. I'm not doing this to show off, I swear to God. My subnet mask is 2525. 2525. Okay. That's what my router uses. You can check yours too. I guarantee you it's different. It might be 0 at the end or 0F, 0 on the third octet. Each number, then the period is called an octet. So it's octet 1, octet 2, octet 3. Here, let me put this over. Octet 1, octet 2, octet 3, octet 4. They're called octets. So you might have a 0 here, you might have a 0 there, or even here sometimes. It's rare though. I haven't seen a 0 there in a while. But you know, you can check it if you're curious. I won't make that extra credit or anything. Connects to a switch trunk link. Well, what the hell does that mean? I'll show you what that means. Functionality is the same as using a traditional routing model. So it works the same as traditional routing. Here's what it looks like. Here's a topology in which there is a router and the switch and some end hosts, which would be the server and PCs. Two different VLANs have been created on the switch. So here's one virtual network, here's two other virtual network. See how that's 2.10? Remember, different addresses and 1.10. Sorry, that's something bad. The router's interface is divided into two sub-interfaces. There are two different VLANs, which will act as a default gateway to the respective VLANs. The router will perform inter-VLAN routing, and VLANs will communicate with each other. So I'll explain it. Would send this to here, back down to here, until, hey, you have to go from here to here to here to here to go to here, blah, 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 which I mentioned earlier. But this is on a stick method. This is why it's called on a stick. They're all different. If we go back, I'm just doing it if you can see the picture. Give me a second. See, this is not on a stick method. This is no way on a stick method. See, there's two different lines of the router. Here, there's only one. They all connect, they're all virtualized through the switch, and they connect to one. That's why it's called on a stick. Sorry, I meant these three methods up here. That's on a stick method. Let's get to switch-based routing. This is a little different. Application of inter-VLAN routing by layer 3 switches. See, we have the router, it talks to a switch, but look at the switches connected to both VLANs. It's a little different. The interfaces between everything, which is pretty weird. But, I mean, I don't see these that often anymore. It's well, not that I don't, but most VLANs don't operate. Shoot, let me try to rephrase this. It's hard to phrase what I'm trying to say in the sense, because you get cabinets of switches that act as VLANs, yeah, but they don't have the router anymore. Connected that directly. The router is like somewhere in a different part of the building that handles everything. These are big routers, these aren't little things. Anyways, network division. Inter VLAN directing permits network chairman to partition organization into various intelligent portions of VLANs. Each VLAN can have its own IP subnet, which have its own IP, right? Look at that. They're all different. And security approaches with further developments of network exclusion and security. They all operate differently and independently. Virtualization. Inter-VLAN directing is a fundamental part of an organization's virtualization, which empowers different virtual organizations. Oh God, that's a big word. Sorry. Coincide on similar actual organizational foundations. This empowers productive utilization of assets and takes into consideration better organization adaptability. It just means you're more flexible. Load adjusting. Inter-VLAN directing can be utilized to stack balance traffic between VLANs. By circulating traffic across different VLANs, networks heads can forestall bottlenecks and further develop network exclusion. So it just helps you moderate things and better help the flow of traffic so you don't have collisions or slowdowns. Inter-VLAN directing can be utilized to apply access control strategies to traffic between VLANs. For instance, network managers can utilize access control records, leg tenants, to control traffic with VLANs, implement security strategies. Voice over IP inter VLAN directing is based for voice over IP executions, which require various VLANs to help various sorts of traffic. Voice over IP, VoIP. Traffic should be isolated from different sorts of traffic to guarantee nature of administration, quality of service, QoS. And VLANs, steering and power system. So what it means is, if you have a voice over IP, what's voice over IP? It means you do telephone over the internet, like we do at work. They're their own separate VLAN. They don't talk to any other VLAN. It's because those can generate a lot of traffic. Believe it or not, they generate more traffic than your computer half the time. So moving on, let's talk about network security best practices. Let me get some water. Give me 1 second, guys. I'll be right back. All right, network security best practices. So what is network security? Network security is the protection of the underlying network infrastructure from unauthorized access, misuse, or theft. You can steal a network, in other words, take it over. It involves creating a secure infrastructure for devices, applications, users, and applications to work in a secure manner. Network security best practices. Segment. Keep compartmentalize. The first best practice is to segment. I'm doing only 5 of these, by the way. The first best practice is to segment your network into zones, hence the VLANs, right? Best network segments for a perimeter-based network firewall in a small organization are designed to isolate from external networks. Make creating a demilitarized zone, a DMZ. We will make one, don't worry, with our server when we get there. And internal network. Internal network zones may be created using functional or business group attributes. Examples of business groups include HR, finance, R&D, research and development, visitor Wi-Fi access. I've talked about this a little bit, but not visitor Wi-Fi access. That's the most basic Wi-Fi access you can get. It's the slowest on the planet, and it's super filtered. Like you can't look up, what can't you even look up, like cars or whatever. Like it's really filtered. You go to Kaiser, you'll see what I mean if you have Kaiser. You filter it so bad, like, dude, I can't even look up hockey, like, because violence is a keyword in it. I'm like, geez, okay. Examples of functional groups include web, database, email, core network services like DNS and Microsoft Active Directory, which we'll get into a little later, and IoT services, Internet of Things like building management or surveillance systems, smart stuff, smart TV, smart camera. Segmented networks enable the setup of least privileged access across zone boundaries. This is the foundation of zero trust and our next security best practice. Moving on. That clang you heard was my keyboard. Just, I don't know why, the toggle buttons don't want to work in here. Just have to click, I guess. Trust but verify. In a zero trust model, data can be considered the new perimeter. Access to that data is allowed only to the people, devices, systems, and applications that need it as a part of their defined role. So, for example, this is why I bring up money. Would people in, let me think of a department, research? No, I guess they would. Here we go. Let's say you have not cooking, cooking's not the word, catering department where you work. Just roll with it, okay? And they make lunch for you guys every day and feed you, and company provided. Would they need access to the financial records of the business from accounting? No. So they wouldn't have access to it. That's essentially what I'm trying to implement here with the role-based access controls. So to implement zero trust, deploy role bases across controls and identify management systems that can verify access. This includes using multi-factor authentication for people. We started rolling that out. Ensuring the device or machine where they are making the request from complies with company requirements is not infected or rooted state. So infected, obviously when that means rooted means it's cracked or hacked. And there has like a keylogger and crack. Using PKI-based certificates to verify and identify applications and systems, that's just like a security check. PKI is a digital certificate that's signed and authorized by the, but I believe you think it's allowed to run this, and it checks it with the server when it runs, and it says if it's good, it runs. If not, it won't let it run. Once verified that connected context and device can be monitored for any change in status or state. So, securing Internet of Things. Internet of Things security is an extension of the trust but verified best practice. IoT devices connected to the network are ubiquitous today. So there's just a ton of it. That's what it means. Like iPads, like Shadow IT. Employees must connect IoT devices to the network without first getting approval. That's true. They can't connect it, but it won't. Well, yeah. You can take an iPad out of the box and get any wireless if you have the password, so that's what it's referring to. Fortunately, there is a good chance the devices won't run if it is exposed to the internet, it has a good chance of being discovered and compromised by bot networks. I'm sorry, excuse me. Companies can discover the device when they're connected using products that specialize in IoT for different industries such as enterprises, healthcare, manufacturing, and utilities. All industries are vulnerable to enterprise IoT devices, such as IP cameras, HVAC, it means AC units, and like heaters and stuff, or building management systems, like keycard systems, door lock systems. So fire alarms now are moving into this too. They're no longer analog based, which means just phone line, including solutions that can detect these IoT devices as well. In industries like healthcare, manufacturing, and utilities, they use sanctioned IoT devices, so they're configured and locked by the IT department in production. But security controls that do not impede the IoT device's normal functions. Securing IoT devices involves discovering and classifying the IoT device. So, for example, we use iPads, and it's called an MDM manager, mobile device manager, so we can push policies that have what's called a token to connect to the network and make sure you can only download stuff we tell download or lock out features like the App Store. They're not allowed to use it, things like that. Automatically segment the device using firewall policies, so they're on their own VLAN. No one, they're not in conjunction with anything else. Prevent exploits of known vulnerabilities using IPS technologies, intrusion prevention systems. So, guys, slide 43. We're almost there. 3 more slides. Enable security. That's pretty straightforward. Change security settings from detected to prevent. First, enable security that matches the data, device, user, or system that you're securing, including safe internet access. Users accessing files on the internet will need advanced threat protection technologies such as sandbox and content disarm reconstruction to protect them from the slide. Well, what does that mean? So those are you download a file, it might be infected. Your company will have a program that will destroy it and then rebuild it as a clean file. That's what that means. I haven't used any, to be honest, but they look cool. CDR enables them access to only safe files while the files are emulated in a virtual sandbox to watch for maliciousness. See? So, likewise, users should be protected from visiting sites that are malicious and serving up drive-by malware. So you ever been on a site, like let's say Yahoo, it's even happened to me, and I click on to read a story about, I don't know, rainfall coming soon, whatever. Then it redirects me that I'm a winner. Click here, $1,000. That's what's called drive-by malware. No user is safe from being targeted. From spear phishing or anti-phishing protections are vital as well. Spear phishing is just targeted social engineering, like when they email like, hey, your password needs to be updated, IT department says so, and there's like no name, it's very general, and they just email you. That's what they mean. That's spear phishing. Anti-phishing protectors are vital. Yeah, it's just filters. That's what they are. Secure data. Prevent the inadvertent loss of sensitive data with data loss prevention technologies. Users sometimes inadvertently or out of context may send work to a personal email. Yeah, we don't do that. If you're working somewhere, don't ever send yourself to your personal email that doesn't pertain to work. That makes sense. The open technology provides security and visibility into how employees are using company data. Device security. Firewalls, we talked about, enable control of large groups of computers, but sometimes granular devices security is needed, like locks, physical locks. For example, if you're working in IT, you'll have keys to everything because you need them. But should, I don't know, a student be allowed to just meander and walk into the server room? No. Physically lock it and restrict access. That's what that's referring to too. Device security products that secure laptops, lock cables, if you want to like mount them or whatever. BYOD devices apply the zero trust model, microsegmenting best practice. BYOD means bring your own device, like your own laptop, and creating best practice security layer for these mobile devices. So essentially, if you bring it, they have to agree to your rules. You can't search this, you can't do that. And if they do that, you kick them off the network and ban them from the network for a determined amount of time, which will be up to you. I don't know. You can ban them for a month, you can ban it for a year, or go talk to HR or whatever you did wasn't right, what have you. Endpoint security and EDR solutions that protect laptops and computers with anti-ransomware that detects when files are at risk, can automatically restore files to a safe state, and can provide rich and detailed information of how a malware infection started, even from connecting a malicious USB. Yeah, this is what happened at work recently. So we have a computer repair class in our. I'm rubbing my forehead and trying to specifically remember when it happened, like a week ago or 2 weeks ago now. At our adult education center, we have a computer repair class. They have bunch of computers in there and they're all networked and they hook them up and they work fine. But in the morning, they have an English class in there. Why? I don't know. Someone plugged in a flash drive and just causes a big old incident where ransomware tried to hit it, and we immediately shut the port down. We locked the machine down and we collected it for refurbishment. So essentially we wiped it clean and put it in a hard drive so it can't be infected. That infected hard drive got destroyed. So That's why endpoint security is important. We have monitors and alarms in place when that stuff happens. That tells us and emails us. I can't show you that email, unfortunately. That's a little too high up the confidential food chain, guys. Sorry. Mobile threat defense solutions protect bring your own devices, and company-owned mobile devices from malicious apps can detect when a device is rooted or jailbroken. You may have heard rooted before. I mentioned it earlier. Jailbroken is more on the Apple side of things, where you can essentially, you could in the past side load a different version of iOS that was jailbroken, like back iPhones and iPods. So you don't know what that is, I'm sure, were popular and they looked similar. You could essentially copy over a cracked or jailbroken version of the iPod iOS onto the phone and still function as a phone, but as an iPod. They could do all these different things that wasn't supposed to do, but it still work. It's essentially what it would do. I don't want to get into it. When combined with an MDM, mobile device manager, or UAM, universal equipment manager, that's what that means. Solution only compliant mobile devices can be allowed access to corporate assets. Cloud native security, cloud technologies, virtualized networks, workloads, and application. Securing hybrid data centers, which means both cloud and physical, and hybrid cloud, which means physically cloud you're hosting, public and private cloud, which, I just mentioned technically. Infrastructure requires cloud native security technologies that are agile, which means they can scale pretty quick. I.e., as these infrastructures grow or shrink, agile. These can be achieved with DevSecOps, i.e., including security and DevOps, CI/CD pipelines. Don't worry about that. To automate security, prevent threats, and manage posture across multiple cloud and hybrid environments. So, on to slide 44, guys. More practices continued. It's 5 of them. There's just a bunch of sub ones I have to cover, guys. I'm sorry. Security is a process, not a product. People look at security as a product. It isn't. It is a process. Be cyber aware and use this threat intelligence to your advantage, and what this means when applied to network security. Create and communicate your security plan. Primarily, this means having a security plan in place and communicating this to your employees to ensure they follow company guidelines. This, along with employee training, will help increase their awareness and provide guidelines for them to follow as well. It's pretty straightforward, guys. It isn't rocket science or brain surgery. I guarantee it. Or brain science or rocket surgery, as some people say. Build a resilient security. The likelihood that any company, will be attacked is high. So it's important to design and create resilient security systems. Here's the thing, guys. You always hear about cybersecurity, and it was popular in the past. Cybersecurity this, cybersecurity that. Now it's AI this, AI that, right? Well, let's take a step back for a second and talk about cybersecurity. You can't prevent everything. Risk, no matter how much you try to mitigate it, will always be there. And if you work in cybersecurity, you will find out relatively one way or the other. Until something happens, you won't have the money for what you need to fix or patch or whatever. So you'll run that risk. Until the day something happens, you can go, hey, I told you so, here's in my report, you covered your butt. And you show them, and guess what? You get your budget's went up like 250% for like a year, so you can get all this fixed. This is the nature of the beast. So, audits, auditing regularly. Performing regular security audits can identify vulnerabilities in systems such as open ports, insecure protocol using Telnet. That's very old. God, Telnet, that's from like the 80s. And configurations that are not secure using default passwords like admin and admin. Yeah, don't do that. Change your passwords, kids. Change your passwords on your routers. Make sure it's not admin. Auditing's can be quarterly or every 4 months or every half year, depending on how you score on the audits. That's a whole different industry animal, which I'm not going to get into, but just so you're aware. All right, security is a process, not a product. Continue. Security maintenance. The top consideration here is to regularly back up and update your security systems and other connected network devices. Pretty straightforward, right? Security challenge control. Having a change control process in place reduces configuration errors, ensuring changes are tracked and their effect is analyzed and gauged. That way you would do in a virtual environment like you would a server to test. Again, you got to test it before you deploy it. You just don't put it all nilly-willy. Optimize security. In addition to performing regular audits, security systems should be monitored to ensure they're performing well as devices are added to the network or more load is placed on the network. Optimizing also goes hand in hand with scaling. This is where you would scale if it was a cloud-based security system. It just requests more server racks or whatever you need. You would request more of it. And you would get it hypothetically in theory because, cloud's very agile and can scale as your needs grow. It can even be automated to an extent. Be proactive. Sophisticated threat actors plan their attacks by doing reconnaissance. I mentioned reconnaissance is the first thing they do. Researching their target and creating multi-vector and like multi-pronged and targeted attacks. So, well, Janice from accounting, who really doesn't know technology well, I just bring up accounting, don't worry. I'm not picking anybody named Janice. It's not the point of this. She barely doesn't know computers, but she knows how to work it. Well, she, reads this email and falls for it. That's the mean about targeted. They will look at people's LinkedIn, like I mentioned earlier about MGM. They will look at just trying to figure out who's the weakest, like you say, weakest link in the chain is what will break the armor usually. This may mean registering a domain similar to your company domain and using creative attractive phishing techniques that will trick users into unknowingly giving up their credentials. That's why I talked about a little bit, but the MGM was a little bit different. They pretended to be the guy. That was social engineering. So this is the end of the first part of Unit 2. Talked about routers, switches, access points, APs, firewalls, and security appliances, which includes firewalls, UTMs, and email filters. Oh God, whatever else I talked about, guys. I can't think of it right now. It's a bunch of stuff. VLANs and routing. I know that part was a little sticky, guys. I do apologize. It was a little, tricky even for me. Trying the best I could do to break it down. Don't worry. I don't think I'll have too much on that in the midterm. I'll mention a question or two. Don't freak out. I'll talk more about the first two and networking security because that's a thing to me is more important in this class than VLAN and routing because we don't really aren't going to make VLANs. Honestly, guys, I know it's towards the end of the video for this end of the second part of the first part of Unit 2 because I don't have the software for it. We're supposed to have NetLabs, but there was a flood about a year ago. We're still rebuilding it. So hopefully by the summer or next spring, we have it all up and running. That's something I'm working on bit by bit. It's not exactly the easiest thing to get back up and running, especially when your stuff was buried in water. I'm not going to get into it. You didn't hear that from me, but I'm just letting you know. And yeah, but we're not to the midterm yet. We're only second week, So end of the first part for the second week, on to the second part of the second week, and then your labs, which I will create hopefully tomorrow, Friday. Till then, guys, take it easy. I will catch you in the next one.